Okay, we'd like to go ahead and move on with section 2D.1, which is geometric series. But before we do that, I want to go ahead and mention one other thing as well about the arithmetic series. We know that if a series is arithmetic, then we can provide the algebraic expression or formula for it by using this. One of the questions that I'd like to pose of you is to think about how that comes about. Why does this work all the time for arithmetic sequences? So that's something that we can go ahead and discuss during class, but if you can already go ahead and come up with a procedure by which you can actually generate this general formula, then do so. And let's see what everybody comes up with. Okay, we need to move on though from the arithmetic sequences to what is called the geometric sequences. So let's go ahead and define it. Are defined by a common ratio between any two successive terms. Okay, so notice that there's a difference now between the arithmetic sequence and the geometric sequence, because instead of talking about a common difference, we're now talking about a common ratio. So how do we go about making that generalization in a very mathematical way? So we can say this: if we have any sequence that is geometric, okay, what this means is if and only if R is going to be equal to u sub n plus 1 divided by u sub n for all n being a positive integer. So notice that what we're referring to here again is a common ratio, and that's the reason why we are going to be using this R for the ratio. Okay? So basically what we want to be able to do then is how do we generate the algebraic expression for the entire sequence once we know that it is in fact geometric. So if we know that a particular sequence is geometric, we can use this formula here. So notice again we're starting off with the first term, and what we're going to do is we're going to multiply that first term by the ratio to the n minus 1 power, again where n is an element of C positive. Okay? So if you know what the first term is and you know the common ratio, you can always find the general expression in a formula form for the geometric sequence itself. So let's go ahead and take a look at an example of a geometric sequence. Let's go ahead and take a look at this example here. Okay, let's say for example 2/6/1854 ... Now if we go ahead and take a look at what the difference is, of course if we wanted to check to see what type of sequence this is, notice that the difference of course is going to be obviously not the same. But if we were to go ahead and take this value over here divided by that value, that's going to be 3. If we take this value here divided by that value will also be 3, and that's going to continue for this particular sequence. So we know for a fact that this is geometric because this is true for all n being an element of Z. So what we can do then is we can then go ahead and say, well, what exactly is the representation of that sequence? And we can say that, well, it's going to be u sub 1, which is 2, times it by whatever the ratio is, and we already said that the ratio, which is u sub n plus 1 divided by u sub n, is just going to be 3, raised to the n minus 1 power. So, there you go. This is what this is going to look like. So let's just go ahead and verify that this is true for this particular sequence here. So if we go ahead and say that n is, say, 1, 2, and 3, and we know that u sub n is going to be 2 times 3 to the n minus 1 power, well, then u sub 1 is going to be 2 times it by 3 to the 1 minus 1, which is, of course, 0. So that means that that value is going to be equal to 2, because 3 to the 0 is 1. So u sub 2 then is going to be 2 times it by 3 to the 2 minus 1. And we know that 2 minus 1 is 1, so that's going to be 3 to the first, which is 3. So 2 times 3 is then going to give you 6. And for our last term, we can go, our last example here, we can say that this is going to be 2 times it by 3 raised to the 3 minus 1. Of course, that's going to be a value of 2. 3 to the second power is going to be 9. Times that by 2, we come out with 18. And sure enough, as we can take a look, and as we compare what we're coming out with these values for u sub 1, u sub 2, and u sub 3, we know for a fact that those sequence values are actually being generated by this particular formula here for the geometric series, geometric sequence.